Hi everyone, this is Dr. GVR Seshagirirao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today I want to discuss about the concept of hydrodynamic lubrication. As we discussed in a previous session, the bearing classification and so the general bearing types and the bearing important the terminology. Now in this section, so I want to discuss about the hydrodynamic lubrication bearings and the how the mechanism, the what is the lubrication mechanism behind this bearing. So as we discussed in the thick film lubrication and in sliding contact bearings, those bearings are works on this type of mechanism only. So that's why these bearings are called as hydrodynamic lubrication bearings. What is the mechanism and the concept? What is the basic concept? We will see in this session. So in this, so as we discussed in earlier session, the bearings is supplied with so sufficient oil. The sufficient pressure is developed in the clearance space. So when it happens, when the journal rotates about an axis, so that is eccentricity with the bearing axis. So eccentricity already we have discussed in the previous session. So the eccentricity means the radial distance between the shaft axis and the bearing axis. There is some the distance, the gap between these two axes. Then only the clearance is possible inside the bearing, and the well lubrication filled up in this gap. And further the sufficient pressure will develop. So without this eccentricity, so not possible the lubrication mechanism under this hydrodynamic lubrication bearings. We will say so many stages are there, and at which stage what will happen we will see in this concept. So as we told, the load carrying ability of a hydrodynamic bearings arises simply because a viscous fluid resists being pushed around. And these type of bearings, two types of mechanisms are important in these bearings. So what are they? We will see. The two mechanisms are, one is the flow of a viscous fluid in a converging channel. So that is the wedge shape, as we discussed in previous section in hydrodynamic lubrication diagram, the wedge shape formed, the pressure distribution occupied in the shape of a wedge. So that is based on this flow of viscous fluid in a converging channel. This is also called as wedge film. And the second one is the second mechanism to the resistance of the viscous fluid to being squeezed out from the between these two surfaces. Whenever the radial load acts on this bearing, the initial lubrication, so that is squeezed out. So here consider a steady load, that is radial load, take half. So in stage 1, at rest condition, the clearance space is filled with oil. So I will show you in the diagram. See, look at this diagram. This is the first stage in hydrodynamic lubrication. So in this case, see here at start conditions, the radial, this is the radial load, and this one is the opposite force, that is pressure force acting oppositely to the radial load. So in this you can see here the load axis and the opposite force, reaction force, are in a same line. So this at this rest condition, and also that is in this case you already have discussed about this portion, what we called journal. journal or shaft. Journal or shaft. So this is the bearing housing. Bearing housing. So you can say the fixed element. So this is the gap between. So this is a clearance between the moving element and the fixed element. This the moving this space filled with oil. So initially you can observe here there is a metal to metal contact. So why? Because this is the journal bearing at stop condition. So at rest condition. At rest condition there is a metal to metal contact, and these two forces are so collinear. So at a rest condition, already have discussed the bearing clearance space is filled with oil. So here, due to that radial load, the initial whatever oil filled in the gap between the this fixed element and rotating element, thus oil has been squeezed out. That at the bottom. So due to this, some metal to metal exist in the vertical axis in this bearing. So already shown in a figure. So in next condition, next stage, see the second stage, when the journal starts rotating slowly in clockwise direction, so the friction, because of the friction, the journal starts to climb the wall of the bearing surface as shown in figure. So in this at this stage, the boundary lubrication will present. See here. So this one the journal whenever starts rotating in the clockwise direction, the slowly this one also the axis of the forces shifted slightly towards this force right, and this one slightly left at initial condition. So slow rotation is possible in this case. In this, you can observe the slightly metal to metal contact when compared to the rest condition is somewhat better in this case at slow motion. So why? Because the journal whenever rotates, they slowly draws the oil from oil inlet. So this is oil inlet. So slowly the gap also filled with lubrication oil. So in this case, the wear normally takes place during this period. So the boundary lubrication exists in this type of bearing stage. The next one is third stage is the slowly whenever the speed increases, the more oil is drawn in enough pressure drawn in the inside the gap between the fixed and moving element. The sufficient pressure also built up in the contact zone inside the bearing. So that is we can say the float of the journal. So you can see in this figure. See. So this is the load axis, load acting, and this is the opposite force, that is the pressure force. Here slowly the oil filled in this gap. So more oil drawn up. So resultant oil force will act opposite to the radial load. So minimum oil film thickness is possible here. So that is H naught, as we discussed in a previous session. Here you can observe here the oil film thickness is very less when compared to here. So here the H naught is maximum. The maximum oil film thickness is possible. So it means here at this stage there is no metal to metal contact. So not at all, does not exist this metal to metal contact at this stage. So also at this stage we can observe the journal will float inside the bearing. So then only the smooth running is possible, and without any friction and wear loss. So I will show you in one diagram all these stages at rest condition. So already have discussed there is metal to metal contact. At a start condition, so whenever the journal starts slowly rotation towards clockwise direction, so slowly the oil also drawn up in this gap, and somewhat reduced the metal to metal contact inside the bearing at start condition. And slowly the increase the speed, so it means keep on increase the speed. So at this stage, at running stage, so there is no metal to metal contact, so in this case, at start condition, at slow speeds, you can observe. So here also the gap reduced, the clearance between is somewhat reduced. So it means the slightly the load axis also shifted. At acquires full speed, this journal will float inside the bearing. So here eccentricity you can observe, and this is the bed safe action of the lubricant. So it means the pressure, sufficient pressure built up inside the bearing to lift the journal, and as well as to carry these radial loads. So that's why in this type of sliding contact bearings, the lubrication property is very important while selecting a journal bearing. In next coming up videos sections, we will see the design procedure of journal bearing, and what is the procedure for designing a journal bearing, and we will see finally numerical problems. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.